Good evening. First of all, I would like to thank you for allowing me to have an idea about our experience in the artificial intelligence in the diagnosis of diabetic retinopathy in Egypt. I'm Professor Ahmed ELMASSRY, Professor of Ophthalmology, former head of the Ophthalmology Department at Alexandria University, Egypt, and this work wouldn't be completed without the help of my partner, Professor Naha Adli, Professor of Alexandria University, Faculty of Engineering. Also, this work was a collaboration between the Faculty of Engineering and Ophthalmology Department at Alexandria University with the help of Professor Marwan Turki and Professor Islam Shireen. It is a combination between the work of Applied Innovation Center, Ministry of Communication, Information and Information Technology in Egypt with the Ophthalmology Department at Alexandria University, Ministry of Higher Education, Egypt. Also, I'd like to thank Dr. Marwan Turki and Dr. Ahmed ELMASSRY who helped me in the preparation of this presentation. All of us know that the value of artificial intelligence all over the world has been increasing in the last few years. It's a step forward for the high technology to diagnose through the telemedicine. We have 422 million diabetic patients all over the world. 950,000 of them are suffering from blindness due to diabetes and diabetic retinopathy. And by the year 2040, this number will reach up to 640 million diabetic patients who definitely will have a higher incidence of affection in the eye and the blindness. The fundus imaging technology now using the different cameras which are portable, even used over the smartphones, give very high quality of fundus photographs that help in diagnosis of diabetic retinopathy, which definitely differs from the diagnosis of the clinician which are experienced, of course, in the diagnosis of this disease, but how to allow the technicians and ordinary ophthalmologists and the computer to diagnose this problematic disease through simple fundus photography. For example, we use the Optomed Aurora fundus camera, and I don't have any financial interest in this issue. So we have an EG efficient diabetic retinopathy, which is an AI-based automatic grading system for diabetic retinopathy using efficient network for 10,000 diabetic Egyptian patients applied. In Egypt, all the idea that we have about diabetes is diabetic patients in 2015, which is the last study done for the prevalence of diabetic patients, was 15.6%, which is definitely higher now. And there is no Egyptian screening program for diabetic retinopathy for diabetic patients up till now. And this and our work is considered the first in Egypt to use the retinal fundus image to have an artificial intelligence program and screening program in Egypt. And these retinal fundus images are used to detect the diabetic retinopathy using these photographs, and there is a need to establish a screening program using an AI-based detection engine. So the aim of this study is to describe the development and validation of an artificial intelligence-based deep learning algorithm, which is the EG efficient DR, for the grading of diabetic retinopathy and diabetic macular edema in retinal fundus photographs. We have 4 steps for this study, which is first data collection, then human grading, then the data set, and lastly, the AI model. The data collection, we used a software developed by the Faculty of Engineering, the Computer System Department, and they collected the fundus image of 10,000 Egyptian diabetic patients, and these patients' information images are uploaded using secure web application. These 10,000 Egyptian patients were collected with the use of 7 units, including a laptop and the fundus camera, all over Alexandria government and the surrounding areas, and including the ophthalmology department in Alexandria University. All patients' data were done in this system, including the name, and the ID of the patient, and whether the fundus photograph is gradable or non-gradable, and if it is gradable, which grade of diabetic retinopathy and which grade of diabetic macular edema. So they were graded with human graders, and the graders examined the fundus image and they determine the ground truth for the image displayed and is able to write their comments on the software and to upload it blindly without knowing the name of the patient. And every image was graded 3 times with different graders. And in case of disagreement, there is an adjudicator who graded the image to verify which stage of diabetic retinopathy for every image. The second thing, these grading was based on the DR grading system. Whether normal, there is no diabetic retinopathy, mild R1, moderate R2, severe R3, or proliferative. And diabetic macular edema was graded whether non-referable M0 or M1 or referable, depending on the hard axis and the presence within 1 or 2 disc diameters from the optic disc. The AI-based system for diabetic retinopathy human grading, we had 14 Egyptian ophthalmologists. All of them were ophthalmologists of different grades. I was one of this team, and we were certified to grade the fundus image for diabetic retinopathy and diabetic macular edema detection. And we took the certificate online from the Gloucestershire University in the United Kingdom, which is one of the approved universities to give certificate of grading the diabetic retinopathy. And all the graders now are certified graders, and these graders after being certified had revised again the 10,000 photograph to be sure that the grading of the fundus photograph were done with certified graders. And we used the standard 5 grades, and the DME graded using binary referable M2 and non-referable M0 and M1. The results, depending on the artificial intelligence-based system for the diabetic retinopathy dataset, we collected totally 19,378 gradable images and 1,009 ungradable images. The 10,811 patients had at least one gradable eye image, and the statistics are shown in this simplified table, showing the right and left eye, whether there is no retinopathy or there is retinopathy, and the total number of patients were collected down, and whether there is a correlation between the right and left eye and correlation with the diabetic status with the severity of the retinopathy. And again, these data set were done for the diabetic macular edema. And again, the 10,811 patients have at least one gradable eye image, and we classified again the diabetic macular edema, and a lot of tables and statistics were seen. And depending on this AI-based system for the diabetic retinopathy AI model that we did in this study, we solve the diabetic retinopathy problem and diabetic macular edema problems separately. And the artificial intelligence model is based on deep neural networks using the efficient net as a backbone, and this efficient net is known as the rethinking model scaling for convolutional neural networks. And we used a pre-training on Kaggle eye packs for the DR classification program. Lastly, and this is the most important step, we fine-tuned the model on the Egyptian dataset collected earlier. And comparing the fine-tuning algorithm of the Egyptian model with the data set collected before, we found that the diabetic retinopathy referability problem after fine-tuning on Egyptian data was with a sensitivity of 96.9% and the specificity of 95.6% with area under the curve of 0.99, which approaching 1, which means a very highly statistically significant algorithm, which is very valuable in detecting the problem of diabetic retinopathy with the AI system. Regarding the DME referability problem, also after the fine-tuning on Egyptian data, we found that the sensitivity is up to 95.8%, the specificity is 94.44%, and the area under the curve was 0.9877, which is again approaching 1, which means a highly statistically significant values. In conclusion, the AI-based model efficient DR can be used with high accuracy for the grading of diabetic retinopathy and diabetic macular edema using fundus images on Egyptian population. This technology offers the potential to increase the efficacy and accessibility of diabetic retinopathy screening. What's the future work? The next project is on 1 million diabetic patient screening project, which had been approved by the high governmental authorities based on our screening program, AI-based model efficient DR. And the budget of this project is about 20 million US dollar, and it will start next September 2022 for 2 years on 10 universities. Each university will screen 100,000 diabetic patients, and each university will have 10 units for screening, and each unit or station will screen 40 patients daily. It's a very big project trying to cover larger number of diabetic patients all over Egypt. All patients will be analyzed by the AI system, and 100,000 patients will be randomly selected to be regraded by certified human graders. The budget will include also investigations and treatment for referred cases, starting from the fluorescein angiography, OCT, laser sessions, intravitreal injections, and pars plana vitrectomy. Lastly, I would like to thank you all for sharing the Egyptian experience in the AI for detecting diabetic retinopathy and diabetic maculopathy. And this proves that we are on the right track. Thank you so much.